Hello everyone, I am going to explain question number 3rd from exercise 2.1 from class 10. So question 3rd is, show that any positive odd integer number can be expressed as 6q plus 1 or 6q plus 3 or 6q plus 5 where q is a positive integer. So in this, students, we have to prove it by Euclid's division lemma, and for that the starting for question number 1, question number 2 and question number 3 are same. You can go through with question number 1 and 2 in my previous video, so that question number 3 will be easy for you. So here the starting is, let a be any integer and b equal to 6. Now why we selected 6? Just see here, because we have to bring the odd integer in the form of 6q plus 1, 6q plus 3 or 6q plus 5. So here 5 is over there. So B, we should select the multiples of 6. What are the multiples of 6? Multiples of 6 means the numbers which divides 6, means the factors of 6. So the factors of 6 are 1, 2, 3 and 6. This number divides 6. That's why here I am selecting b is equal to 6, because if we will not take b equal to 6, if we will take 2 or 3, then this 5 is not going to, we are not going to achieve this 5. So to achieve this 5, at least b equal to 6 we should take. So again I am repeating why we took b equal to 6. Because we have to bring in the form of 6q plus 1. So everywhere 6 is there with the q. That's why the numbers which divide 6, among them any one we have to select as b. So the number which divides 6 are 1, 2, 3 and 6. Among all these 4 numbers, I selected b equal to 6 because here maximum we need 6q plus 5. That's why we selected here 6. Now we'll move further. By using Euclid's division lemma in A and B, we get. So this is our Euclid's division lemma, because Euclid's division lemma is A is equal to BQ plus R. What I said? A is equal to BQ plus R. So instead of B, we had took B as 6. That's why here 6 came. Now what is R here? R is the remainder. Since R is the remainder, so, and here students, it's actually the division rule. So here 6 will behave as divisor and R is the remainder. So remainder cannot be more than 6. That's why the restrictions for R is greater than equal to 0 but less than 6. That's why the possible values of remainder are 0, 1, 2, 3, 4 and 5. Now why we are able to take so many numbers? Because here 6 we selected. Since we selected here 6, so up to 5 we reached. If you are going to select here 3, then you are going to reach up to 2 only, because the number is going to be less than the divisor. So here we selected 6. Now I hope it's clear to you why we selected b equal to 6. First thing, there are two conditions that what you need in the, according to question, what you need here. So here we need 6. So what are the numbers which divide 6? Among them you have to select the b equal to. And one more thing, because we need 6q plus 5, maximum till 5 you have to reach, so we have to select b equal to 6. Now further, since remainders are 0, 1, 2, 3, 4, 5, that's why here in Euclid's division lemma, instead of r we are going to substitute all these remainders. That will give you the value of a as 6q. When we substitute here 0, then when 1, 2, 3 will achieve all these values of a. Now in the question what we want, just see here, show that any positive odd integer, so we have to select here odd integers only. Odd integers means the integers which are not divisible by 2. So here this is divisible by 2 because 6 we can divide by 2, so it's even. Here it is divisible by 2 but 1 is not divisible by 2. That's why it is odd. In the same way, this is even, this is odd, this is even, this is odd. Why these are odd? Because these are not divisible by 2. So the odd numbers which we selected are a is equal to 6q plus 1, a is equal to 6q plus 3 and a is equal to 6q plus 5. And the reason just write down are odd numbers as they are not divisible by 2. And so what we achieved here, that all the positive odd integers are either are of the form 6q plus 1 or 6q plus 3 or 6q plus 5. That only we have to bring in the question. So this question is completed. So this question number 3 is comparatively simple than question number 1 and 2, because in question number 1 and 2 first we have to select the odd or even integers and then we have to do either the square of them or we have to do cube of them. Here you not have to do anything, simply you have to select the odd integers and we have to show that the odd integer is of the form 6q plus 1, 6q plus 3 and 6q plus 5. So here students, the most difficult condition for any student is to select what is going to be B. So here it's very simple. According to question, B you just assume as 6. And further if you have any doubt, you can write in comments so that I can clear out. Thank you.